Okay, welcome back. Let's come back to the question we have in the last video. If you still remember, we are studying the multi-user accessing the same banking account simultaneously via different ATM machines. If we don't have any protections, we may have very different balances after the transactions. So NX accessing the account via ATM 1 with your $100 and Bob accessing the account via ATM 2 with your $50. The initial balance is $200. The question is, if we don't have any protections, what can be the final balance? To answer this question, we need to know how the system really runs. What is the DBMS and what's the relationship between DBMS versus the ATM machines? So generally, we're running the DBMS on the servers in the banking system. We have a banking server here. It runs the DBMS, maintains all the data there. And in different locations, we have lots of ATM machines which can be connected to the server via the internet, right? These lines denote the connections. And we have two users, NX and Bob. They are accessing the same account from ATM 1 and ATM 2. According to the previous page, the transaction has 4 steps. The first one is to get the balance from DBMS and send to the ATM machine. In the ATM machine, it checks if the balance is larger than $100 or not. If so, then dispense the cash. Then the ATM machine will put a new balance into the DBMS again. It has 4 steps, right? It is similar for Bob at the ATM 2. He also needs to do these 4 steps as shown here. Then the question will be how the system will handle these transactions or these 4 steps. According to our traditional understanding, if they do the transaction in a sequential, for example, we do the NX transaction first and then do the Bob's transaction, or the reverse, the balance should be very safe. Now we have $200, after with your $150, then there will be $50 left. In other words, if the transaction execution process is to do the blue one first and then the red, or the red one first and then the blue, then the final balance they will be the same. They are all the $50 we have, right? However, the DBMS running will have no protections. In other words, when we're executing the blue transaction, the red transaction can cut in at any time. For example, when we're executing the blue transaction for NX, we do the step 1, we get the balance and send to ATM 1. At this moment, transaction 2 from Bob cuts in. So he do the red transaction from step 1 to step 4, and then after this Bob's transaction is finished, we will continue to do the transaction for NX, right? In other words, NX starts the transaction first, or finish the second, right? He starts first before Bob, and he finishes later than Bob. If so, what will be the balance for the account? So by checking this transaction steps very carefully, when do the step 1 for the blue transaction, we get a balance from DBMS. The balance here will be $200, right? And then we do the transaction for Bob. We get a balance from DBMS. The transaction here, the balance here should be also $200. We do the 4 steps and write back the balance to DBMS. For the Bob transaction here, after we do the step 4, the balance we write back to DBMS should be 150, right? Because the balance we have for Bob here is 200. And we do the step 1 to step 4 here. And after we finish Bob's transaction, the transaction here will be 150. And we write back to the DBMS server, right? And we continue to do the transaction for NX, step 2 to step 4. And we write back. Remember, for the step 1 here, the transaction NX gets is $200. And after finishing the transaction, the remaining balance will be $100, right? And then NX also writes back the balance into the server and override the transaction just returned by Bob. In other words, the final balance for the account, if we execute in this way, the balance will be $100. right? This is one possible execution process if NX runs first. However, it is also possible that NX runs first and finish first as well. How can it be possible? Now the NX runs first, do the step 1, get a balance. The balance he gets is $200, right? And then at this moment, Bob also runs his transaction, do the step 1, get a balance from DBMS. The balance he gets is also $200, right? And then NX do the remaining transaction. He writes back the balance into the system. He writes back $100 to the balance, right? And then Bob do the transaction. He writes the balance back to the system. The balance is 150. He overwrites the NX balance. And after its execution this way, the final balance will be $150. Right? You can follow me, right? Of course, we can also have some other cases for the execution process if we don't have transaction protections. However, the possible balance we can have will be 50, 100, and 150. We can have different balance left in the banking account. We use this example to show that we need to have some protections for this multiple user access to the DBMS. It is very important for maintaining a very safe and a very accurate system for the data we have. So probably you have some experiences in programming, like when in dealing with the file system. You may also wonder why the file system will not work for maintaining and keeping records of data. According to the knowledge you learn from the programming course, you know that we can save lots of data in files. The size can also be very big. We can handle the file with some program. Well, to answer this question, we need to see some limitations for the file system. First of all, for storing the data, the file system is very limited. And the size is limited by the disk or the address space. Also, when the system crashes, we may lose data, right? Because the file system is not very safe from the system crashes or failures. Also, even though we can use some password to protect some files, however, in most of cases, the password or the file-based safety, these kinds of protections are not sufficient. What's more, when dealing with files, we need to write a program. And different transactions may require different kinds of programs to run on the same file. In other words, we need to write a C++ or Java program for every new query, which may need to worry about the performance as well. This is a very big limitation. All the file doesn't have enough concurrency protections, and we need to worry about the interfering with other users, like we showed before, right? For the multiple users accessing the same accounts. And we also need to offer different views for different users. What's more, for the data we have in the DBMS, we may have to change the data very often, either the data or the data schema. And however, when we're saving the data in the file system, it's very hard to change the schema actually. So generally, the schema changes may need to change the file format, also need to rewrite all the data we have, and we also need to handle the application we have as well. This is the reason why the file system will not work, and also the motivation why DBMS is necessary. So you can see that DBMS is a very complicated system, and it also requires lots of basic data structure to help us maintaining the data we have in the system. So to model the data we have and translate everything into data structures, we need to have some models for us, which denotes the data models. Formally, data models denote some conceptual structuring of the data stored in the database systems. The data models we can use can be very simple records or the tuples, for example. If we store the data as a set of records, each one will have an ID, for example, and we can also have a bunch of attributes. If we take the students as an example, and we try to store all the students in the class into a DBMS, then each student will be described by a certain ID, like your FSU ID, as well as your name, your address, your courses, and photos, and etc. Besides the records, the data can also be a graph, where the nodes represent the cities and edges represent the airline routes. It's also another kind of data models we can use to model real-world data we have into some data structures. Here we also need to differentiate the schema versus data. Schema is very different from data. We need to make it clear. A schema generally describes how data is stored into a DBMS. It is defined at the setup time, and it doesn't change with the time. Therefore, it is also called metadata, as we see here. And the data actually is an instance of a database system. It denotes some concrete data we put there. And they may change rapidly with time. We can also think in this way, the schema is more like the type, and data is more like variables, as you learn from the programming courses. Or we can understand in this way, the schema denotes the class, and data denotes the objects. If we have learned C++ and Java, right, you should know what I'm saying about. So to help you understand what's the difference between schema versus data, we can also provide one example here in this page. And before that, we can show the difference between class and object first. It can help you understand what's the difference between schema and data as well. Let's assume we're defining one class in a programming language, because we don't know which language we're using right now, and we can write it in a very general way. For example, we can say we define class a car, for example. Right? We define one class. Inside the class, we will have multiple variables, right? Describing what are the properties of the cars. First of all, we can define like the car should have a maker, right? We have one car maker, right? It is a string, and we can also have the string. Let me change the format. And we can also have the model, right? What's the model of the car, for example? And besides it, we can also have like some attributes like the color. What's the color of the car? Right? We can also use string. And we can also have the VIN number. And the remaining ones, and like which year it is built, right? We can use int and etc. Let me reorder this attribute. We can put the year in front before the color. This is a class we can define when we try to define some cars in our program. And when we try to create some objects for this class, we can use some language like this. Let me copy this. We can use the same font. Like we can define one object like my car equals to car, right? We can initialize all the attributes in the car, right, by calling an initialization function. For example, we have the maker. Let me reorganize this. Equals to, for example, Toyota. You can enter different kinds of makers depending on your car you have. We can have model equals to, for example, I'm using the Camry. And the year is like 2017, for example. The color I have is black. Let me use string. And the VIN, I cannot release my VIN for you. So we can enter some numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and etc. In this way, we will be able to create an object for the class, right? This is what we learned from the programming course in define class and objects. When we come to the schema, it will be very similar. However, they are representing different languages. To define schema in a database system, we have to use SQL. But we cannot define SQL here because we haven't touched the SQL yet. I can represent a very general way for the, like, if we also want to represent a car, the car will be like we have the schema name here. It has multiple attributes. We have like a char. We have a name of the char, like 20 char maker. And we have the char, like a 20 size and the model. It's comment. And we have like all the attributes like int. We also have int in the SQL. And we have char. For example, we have like 5 as the corner, as well as like a VRN is also char. Probably we have longer char for him. Then it will be a schema we can define for cars in SQL. We will show this later. And we come back to the data we can store inside our DBMS. Then we can use the table here. When it comes to the data we have, it will be some concrete data samples or data instances. Here we have some different cars. We can have Toyota. We have Camry. We have year. We have corner. We have VIN. Right. We can also have some different cars like Honda, like Civic, like 2015, white. VIN is 3, 4, 5, 6 in essential. And we can also have some other cars like a high-brand car like Tesla, the Model 3, and 2019, like a gray. VIN is 5, 6, 7 essential. And you can have different cars here. There are some concrete examples. So this is called schema, and this one is called data we have in the system. So you can differentiate the difference between these two, right? Okay, so that's it for the example.